Hello, sir. Am I audible? Hello, sir.
Yes, ma'am, you're audible.
Shall I start, sir?
Yes, ma'am.
Good evening to sir and all the warriors of Sambhavam IAS present over here. It is eternal that every day brings unknown opportunities and challenges. I hope you are enjoying this evening after a rewarding day. This is Riya Chakraborty on the behalf of Dia Delhi. Welcome you all on the most awaited class of climatology by our respected, amicable, and empathetic teacher Sandeep Mahajan sir. Children who especially need a positive light in their world can always depend on a good natured teacher who is consistent, fair, reliable, friendly, and who provides a safe and structured environment for all of his students. Our respected Sandeep Mahajan sir is a perfect combination of all the qualities. It is my honor to welcome sir in this class, and I am very much thankful to my seniors for giving me this opportunity on such a day which is very special for all the Bengalis. Because from today, after waiting for 1 year, the countdown of Bengal's most famous festival, Durga Puja, has started. As this is the evening of Mahalaya, I want to start the class by remembering the goddess through some designed words. Madhukaita Vavidam Vidhatri Varade Nama Rupam Dehi Jayam Dehi Yasho Dehi Disho Jai Mahishashuraninashi Bhaktanam Shukhade Nama Rupam Dehi Jayam Dehi Yasho Dehi Disho Jai. Without any further delay, I would like to request sir to please further proceed the class. Thank you. Over to you, sir.
Thank you, ma'am. Thanks a lot. Hello, everyone. Good evening, all. Guys, first of all, let us look at the syllabus, guys. The first basic thing that we need to look is just a minute. I want everyone to note this down properly. Climatology. First chapter that we are going to focus is atmosphere. Second chapter is temperature. Third chapter is humidity and precipitation. Fourth chapter is atmospheric circulation. Fifth one is winds. Sixth is air masses, fronts, and frontogenesis. cyclones. 8 is world climate. 9th is Indian climate. 10th is urban climate. Yes, this is one of the lengthiest chapter and most important and interesting topic as well. And for this, the reference books will be 6th standard NCERT book, 7th standard NCERT book, atmospheric circulation, 11th standard fundamentals of world geography or fundamentals of physical geography. These 3 NCERT books, guys. And what I want you to do is, as soon as we complete the class, that particular topic, if you read in the NCERT, that's enough. Along with class notes, the same thing you need to do. Fine, guys? So now, let us begin with, no need of GC Leonges, I will tell 6th standard NCERT book. Atmosphere. Guys, I began the classes with basics. In that basics, we tried to talk about evolution of atmosphere. I hope you people remember, and I hope you people have attended this class. Once evolution of atmosphere is done, we will be discussing about, like, composition and structure. But before that, I want to discuss about, like, certain characteristics. So what is this that we need to study? See, guys, let us talk about temperature, and pressure. Of atmospheres. So the first basic thing is, everyone look at this. Initially, I'll give you time to write and all, so don't worry about it. Just let me assume this is Earth. This is hot magma. This is also hot magma. So initially Earth was in molten magma. This is first layer, this is second layer. Now, the first layer, I repeat, the first layer is exposed to atmosphere. So what happened? Lot of gases from the first layer started coming out. And as they came out, slowly Earth started cooling. Earth started cooling. Okay. So when Earth started cooling, all these gases did not escape. See, the gases did not escape. All the gases were held by Earth's gravity. All the gases were held by Earth's gravity. Now, first layer released the gas. Now I want the second layer to release the gas. Now for second layer to release the gas, what it does, it comes out in the form of a volcano. It comes out in the form of volcano. When it comes out in the form of volcano, it would reach greater heights. So what I'm trying to tell you is the gases from the cooling of the Earth came down or came out. Once it came out, the process is called as degassing. And inside the Earth, if we have to cool, it is called volcano. And even today, I can see that there is volcanic eruption which is occurring to ensure that Earth is cooled inside. Please understand, I'll repeat again. Even today, why do we have volcanic eruptions? Volcanic eruptions are present even today so that cooling of the Earth will occur. Now, from the two things, what I got is guys, everyone, A and B. A is closer to the Earth, B is far from the Earth. Can you people tell me where you will have high density of particles? Where will you have low density of particles? Where you will have more air particles, where you will have less air particles. Good. So, A will have very high density. Very good. Very good. Very good. B will have less. Everyone, high density. Can you people please tell me in a small area, if I have more air, will temperature be more or will temperature be less? More. So high density leads to high temperature. Can you people tell me, all of us, if we are put in a bus, like lot of people are pushed in the bus, will the pressure be more or will the pressure be less? More. So there is high temperature, high pressure, and high density. But as I move above, there will be low density, low temperature, and low pressure. Did we study this, guys? Did we see this before? Did we speak about low pressure, two types of low pressure? Thermally induced low pressure and dynamically induced low pressure. Okay. So guys, but this you have no, have you written this? Okay. Yes, yes. Just have this, ma'am. Those who have not, just I'll give you 1 minute. Just draw this heading as, everyone put heading as pressure and temperature. Pressure and temperature, and draw this. Okay. So now, from this picture, pressure and temperature. Heading. Now, can you people tell me, there is a formula which says PV is equal to RT. And guys, when V is constant and R is constant, P is directly proportional to temperature. Yeah. P is directly proportional to temperature. Is it correct here also? Can you all check? High temperature, high pressure. Low temperature, low pressure. Okay. But in geography, some changes occur. We will learn that now. First is, everyone, please see here. I have Earth surface. Now, for our convenience, I'll write two boxes. Guys, in this box, air particles are less. In this box, air particles are more. Wherever air particles are less, we call it as low pressure. Wherever air particles are more, we call it as high pressure. Please understand, pressure is dependent on the number of air particles. So wherever air particles are less, we will call it low pressure. Wherever air particles are more, we will call it as high pressure. Now everyone, let us try to apply this for this particular case. Now, this is Earth's surface. Due to sun's heating, this region of the Earth got heated. This became hot. As this became hot, the air above also became hot. And air has a property. When air is hotter than the surrounding, when air is hotter than the surrounding, then the air rises. Whenever the air is hotter than the surrounding, air rises. I have rising air. Now my question to you is, in this area, will you have less air particles or more air particles? As all the air went up, in this area, I will have less air particles. Less air particles means low pressure. Everyone, less air particles means low pressure. And surrounding area, I have high pressure. You see here, surrounding area, I have high pressure. But in this area, particles reduced, so it became low pressure. The tendency of air is always to move from high pressure to low pressure. The tendency is to move from high pressure to low pressure. Now you all tell me, when the earth is hot, air went, wind came from high pressure to low pressure. If it comes here, will the earth heat it again? You tell me, if it comes here, will the earth heat it again? And will the hot air go again? Will the hot air rise again? So, what am I observing? Here, I am observing air is converging and air is rising. Guys, now can you people tell me, why is air rising? Is it because of temperature or is it because of convergence? Why is the air rising? What is the main reason for air to rise? Temperature. So can I say wherever I have high temperature near the ground, guys, wherever there is high temperature near the ground, there will be converging and rising air. Please understand this. Any time from now on, if I ask you what is low pressure area, what is a low pressure area? If there is converging and rising air. It is called as low pressure area. I will give you another example. Now, I have a cold air and I have warm air. From one side, cold air is coming. From another side, warm air is coming. Now, when cold and warm air comes together, this is not ocean currents, this is air. So when warm and cold comes, can you tell me which one will rise, guys? When cold and warm hits, which air will rise? See guys, cold air is having more weight. Warm air will have less weight. So what is going to happen? Warm air would rise. Good. So I have cold air and warm air. Warm air started rising. Now guys, earlier warm air was 1000. Cold air was 1000. That means 1000 particles were there. Now some particles, let us say 100 particles, are going above. That means guys, in this region, will you have less air particles or will you have more air particles? If warm air rises, will you have less air particles or more air particles? If you have less air particles, can I call it as low pressure? Can I call it as low pressure? Now I want you people to tell me, here also, can you people see there is rising air? There is also what we call as converging air. So what is the meaning of low pressure? Low pressure anywhere means there will be converging and rising air. Ma'am, there are two things, ma'am. One is warm air and cold air is based on temperature. We are not talking about moisture. Fine. So cold air weight will be more, density will be more, and warm air density will be less. So it rises. So we'll talk about moisture. There I will explain you the moisture. Now a simple question to you all. What is the difference between this and this? What is the difference between 1 and 2? Both are low pressure. But what is the difference between 1 and 2? In one, listen everyone, in one, Low pressure is because of high temperature of the earth. In one, low pressure is because of high temperature of the earth. In two, low pressure is because of convergence of cold and warm air mass. Clear? Now this is called as dynamically induced low pressure. Dynamically induced low pressure. And this is called as thermally induced low pressure. Yes. Guys, in both the cases, I have low pressure. But here, the low pressure is because land is hot. If land is hot and if there is low pressure, then it is called as thermally induced low pressure. Everyone, if land is hot and air above is low pressure, then we call it as thermally induced low pressure. But if there is normal land doesn't have any temperature. That means, let's say normal land is neither too hot nor too cold. So when land is not too hot or too cold, but still I am having low pressure. And why am I having low pressure? This is because cold and warm air converges. So as cold and warm air converges, warm air is rising. Now here, as Earth's temperature is not involved, we call it as dynamically induced low pressure. I repeat, as Earth's temperature is not involved, we call it as dynamically induced low pressure. Guys? Okay, any specific temperature for air to rise? Temperature should be more than the surrounding temperature, then air rises. Everyone now, can you people tell me Earth equator? Let me assume this is 20 to 20. This is 20 to 60. 20 to 60. A, B, C. Can you tell me which region of the earth will be hot? Which region of the earth will be hot? A. Okay. So can you tell me where will you have thermally induced low pressure? Where will you have thermally induced low pressure? A. Good. Now the next question I have is, where will you have dynamically induced low pressure? B and C? B and C? Yes. B and C? Yes. Very good. Guys, now. Cyclone means low pressure area. Please understand, cyclone means low pressure area. Can you tell me tropical cyclone? Tropical cyclone. That is, which is in between 20 to 20 or 23.5 to 23.5. Tropical cyclone, 23.5 to 23.5. Can you people tell me, will it be thermally based, thermally induced, or will it be dynamically induced? Tropical cyclones are thermally induced or dynamically induced, thermally induced. Do you understand the concept now? Can you write? Can you write? Pressure and temperature. Pressure and temperature. Below this, you write low pressure. Low pressure. Hyphen. Low pressure is an area. Low pressure is an area where we observe converging and rising air. Converging and rising air. Okay, guys, from now on, when I ask you what is low pressure, you should not tell me high temperature, because you know that not only high temperature, even if there is no high temperature, still you can get low pressure. Okay, many students do that mistake. So can you draw this? Low pressure. Good. You write below. Thermally induced low pressure. Below this, thermally induced low pressure. Hyphen. Whenever Earth is hot, comma, air above the earth will also be hotter, due to conduction. Whenever Earth is hotter, air above the earth will also be hotter due to conduction. Full stop. As the air rises, we observe low pressure. Near the hot earth surface. We observe low pressure near the hot earth surface. Full stop. Surrounding region will have high pressure. Full stop. Air would converge from the surrounding region towards the low pressure, comma, it gets heated and again rises. It gets heated and again rises. Full stop. Till the earth is hot, till the earth is hot, we would observe low pressure. We would observe low pressure. Full stop. This type of low pressure, this type of low pressure is known as thermally induced. Thermally induced. Draw this, guys. This one. Yes, have a proper notes, guys. For geography, I will give it to you in such a way that you don't need to refer anything else. If you are reading any material, if you are reading any book, it is only for language. That is how people speak in different languages. Nothing more. Conceptually, any question you can answer with the help of class notes, even for prelims or mains. So don't worry about it. Make a proper note, write it in such a way. See, now I have written LP, HP. Like, at home after class, please try to write high pressure, low pressure. You don't use shortcuts, because next year, when you open the notes, when you have to revise, you should not get confused. Done, guys? Can I move? You write below, dynamically induced. Dynamically induced. Hyphen. Below this, whenever warm and cold air, whenever warm and cold air converges, comma, cold air is denser. Cold air is denser. And warm air is lighter. And warm air is lighter. Due to this, warm air rises. Warm air rises. Full stop. As warm air converges and rises. As warm air converges and rises, we observe low pressure. We observe low pressure. Full stop. Here, low pressure is not formed. Here, low pressure is not formed due to Earth's temperature. Due to Earth's temperature. So it is called dynamically induced. Dynamically induced. Draw this, guys, and from next class try to have blue, black, red pens so that you can represent in your notes better. Done? Good. Yes. Yes, if screenshots can be taken, just ensure you take them so that, like, we can continue with the classes. Okay. Now, let us assume that everywhere I have air particles. Geography is very simple, guys. It is just understanding our nature. And for every IAS officer, geographical knowledge is important so that he can help poor people to live their lives. 90% of our people, like, come in middle class and lower middle class and poor. And within that, 40 to 50% of the people are dependent on agriculture. And if you want to change the lives of the people, you need to understand the agricultural aspects which are dependent on, like, these things, geography. So if you can guide the farmers properly, because due to climate change, many things are changing. If you people can guide them, this is how you need to do. This is there in the market. Like, that would change. But for that, you should talk to them in the language where they are comfortable. So now you see, land is cold. If land is cold, air above will also become cold. So what is going to happen? All the air whichever is there, slowly it will become cold. Now you tell me, cold air means if the weight increases, if the weight increases, will it move upwards or will it move downwards? If the weight increases, will it move upward or will it move downward? So what is going to happen? All the air particles started moving downward. Now, please see here. Can I say in this region, I have more air particles because all the air from above have come down. You tell me, if you have more air particles here, can I say it is high pressure? And as you have high pressure, can I say surrounding will be low pressure? Surrounding is low pressure. If surrounding is low pressure, wind will blow from high pressure to low pressure. High pressure to low pressure. Guys, what are the two processes here? What are the two processes here? There is descending air and there is diverging air. Good. Everyone, two terms. Two terms. What are the two terms? Low pressure means converging and rising air. High pressure means descending and diverging air. Clear? High pressure means descending and diverging air. You tell me now, is it occurring due to Earth's surface being cooler? If Earth's surface is cold, can I call it as thermally induced? High pressure. Can we call it as thermally induced high pressure? Now, guys, I have the land. I had air particles. Somewhere above, I have a cold air. Somewhere above, I have a cold air. Due to many reasons. Reasons we will read later. Due to many reasons, I have cold air here. Cold air became denser and it started coming down. Land is not cold, guys. Land is not at all cold. Land may be of a different temperature. It came down, it hit. After hitting, one branch went like this. Another branch went like this. Here also I am observing descending and diverging. Can you tell me what type of high pressure is this? Very good. Yes, I'll give you an option. Just check and tell. Converging and rising air. Converging and descending air. Descending and diverging air. Descending and converging. Okay. Now, in a subpolar low pressure area, in a subpolar low pressure area, what will be observed, guys? Please check, please see the word, don't go with the things. What is low pressure? What is low pressure? Achha, achha. What is low pressure? Low pressure basically means, forget what is subpolar. I didn't teach you subpolar, you leave subpolar. But what is the meaning of low pressure? Low pressure basically means converging and rising. Some people are still going with converging and descending. No, guys, it's not converging and descending, it is converging and rising. Anywhere, forget about another terms associated with it. Forget about any other term associated with it. I just want low pressure. What is the meaning of low pressure? Converging and rising. Fine. So, can you write high pressure? High pressure hyphen it is an area where we observe descending and diverging air. Descending and diverging air. There's a lot of areas we will be reading this case and it will be helpful for us. Descending and diverging air. Can you draw this quickly? Next is, you write thermally induced high pressure. Thermally induced high pressure. Hyphen. Whenever Earth is cooler, air above the earth, air above the earth will also be cooler. Air above the earth will also be cooler. Full stop. Cold air would be denser, and it descends. Cold air would be denser and it descends. First, the descending air would diverge. The descending air would diverge. Which leads to high pressure area. High pressure area. First, this is thermally induced. This is thermally induced. Draw this, guys. Okay. You write below. Whenever air descends, irrespective of the Earth's temperature, whenever air descends, irrespective of Earth's temperature, then the air diverges. Then the air diverges. First of all, descending and diverging air leads to dynamically induced high pressure. Leads to dynamically induced high pressure. Draw this case quickly. Okay. Guys, just take 5 minutes break. We'll meet. Yes, Chris. Thank you for your patience. So now the next one is from this topic every year. From this topic every year, at least one question will come. Okay. See, what is high pressure? Whenever air particles increases in a particular area, then it is called as high pressure. Whenever earth is cold, right? Whenever earth is cold, air above the earth will also be cold. So if air above the earth is also cold, all the air particles will come closer. As the particles come closer, I will say there are more air particles. So it is called as high pressure. And surrounding, I have low pressure. So here, air is coming closer. That means there is descending. And air is diverging. So we say, wherever there is descending and diverging air, we will have high pressure. Now in this case also, a cold air from above is coming here. You see, when cold air comes here, the number of air particles increases. As the number of air particles increases, it will be high pressure and surrounding will be low pressure. So air will move from high pressure to low pressure. So anywhere if I have descending and diverging air, then it is called as high pressure area. Is it clear now, Sachin? Okay. So the next one is you write heading conduction, convection, radiation, advection, reflection. Because every year at least one question will come from this particular topic: conduction, convection, radiation, advection, reflection. These are different forms of transfer of heat within the atmosphere. Now first everyone, let us say we have fire and one side I'll keep a piece of iron and another side I'll keep a piece of wood. Here iron became hot. Here wood became hot. A and B. Can you tell me which one will become hot? Iron A. Good. See guys, iron became hot because heat is transferred from here to here, like this it moves. But wood, heat will be transferred till here, but heat is not transferred in these areas. So iron is called as good conductor of heat. Good conductor of heat. Wood is bad conductor of heat. Now, what is the meaning of this? Whenever heat is transferred from one point to another, which is in contact, see two words, there should be heat transfer, and wherever there is contact, that is called as good conductors. Now, from this basic idea, I want you people to tell me now. I have a candle. This is one layer. This is one layer. This is another layer. A, B, and C. Guys, if I keep my hand closer to A, it will be hot. Correct? But near C, will it be hot or will it be cold? Near C, will it be hot or will it be cold? Little cold, comparatively cold. Very good. Good. Now you tell me, did heat transfer from A to B or B to C, guys? Was there heat transfer? If heat transferred, guys, if heat transferred from A to B and B to C, then why C is not hot? In wood, you tell me now, in wood, was there heat transfer? No. Air also there is no heat transfer. In air also there is no heat transfer. Now I'll tell you similar aspect you see here. Earth is very hot. 0 kilometer A, 1 kilometer B, 8 kilometer C. Yes, can you tell me from the earth, because earth is hot, air layer closer to earth will also be hot. But will C be hot, guys? Will C be hot? No. Is A hot? Is A hot, yes or no? Good. Why is A hot? You see, it's like this. If wood is kept in the fire, at least the portion which is in fire will be hot. Remember this. At least the portion which is here will be hot. Now here, earth is hot, At least the air which is touching the earth will be hot. But away from it, it is not hotter. So from this, can you people tell me, is earth, ma'am, wood is not transferring the heat, ma'am. Iron is transferring the heat. This is the reason every body will have a property. So let us say for cooking, if I try to use wood based spoons, my hand will not have any effect. If I use steel blades and if I keep it for long, my hand will also become very hot because of good conductor and bad conductor. Yes, I am not entering into the metal, non-metal concepts because technical words, if we use, many students from other background will not understand. So let's make it as simple as possible. The basic concept here I want you to remember is air is bad conductor of heat. Air is bad conductor of heat. The basic concept that we should all understand is air is bad conductor of heat. This is the first thing. Second, because this is A layer, this is B layer. I am heating the water from below. I am heating the water from below. Can you tell me which layer will get heated first? A layer gets heated first. Can I say A is hot, B will be comparatively cold? Guys, hot means lighter. Cold means denser. So what is going to happen, guys? Hot water rises, cold descends. Everyone, can you see this? In 6th standard NCERT book, they will do this experiment by putting a paper. And when you heat, the paper circulates. Guys, now I want you to learn a very important line here. See here. Whenever hot is below, cold is above. I repeat, whenever hot is below and cold is above, there will be vertical movement of water, vertical movement of air. Clear? Whenever hot is below and cold is above, there will be which movement? Vertical movement. And this vertical movement is called as convection. In atmosphere, with increase in height, if temperature decreases, what is the meaning? You see, below I have high temperature, above I have low temperature. With increase in height, if temperature decreases, then there will be vertical movement. With increase in height, if temperature decreases, then I will have vertical movement. and this is called as convection. And convection occurs in gases and liquids. Air is bad conductor of heat, but air closer to the earth gets heated. Similarly, here, whenever as I move above, temperature, if it decreases, I will have vertical movement of air. Everyone, now look at this carefully and tell me, I am going to heat it from above. B and A. Can you tell, guys, if I'm heating from above, which layer gets heated first? B. Okay, B got heated. Very good. Can we say B is hot? A is cold? A is denser? It is lighter? Okay. Now you tell me, will cold air move above and warm air come below? Will cold go above and warm come below? No. Cold is denser. If weight is more, it cannot go up. So because of this, there is no vertical movement. Yeah, warm may move above, but there is no vertical movement. Correct, everyone? Is there vertical movement? No vertical movement. So guys, with increase in height, if temperature increases, there is no vertical movement. With increase in height, if temperature decreases, there will be vertical movement. With this concept, I want you to tell me two things. Let us all talk about Delhi, guys. Now, Delhi. Winter is very cold. Land is very cold. Air is also cold. And above this, I have warm. And here, I'll have warm below. Cold will be above. Can you all tell me now where you will have vertical movement and where no vertical movements? Where will you have vertical movement? A will have vertical movement. Why? Warm rises and cold descends. We know vertical. Very good. Guys, if it is the case, I will tell you one simple topic. You should tell me now. This is my troposphere. This is my stratosphere. In troposphere, as I go above, temperature decreases. In stratosphere, as I go above, temperature increases. Now, can you people tell me where will you have vertical movement, where you will not have vertical movement? Troposphere will have vertical movement. and the stratosphere will not have vertical movement. Do you understand why are we talking about this now, everyone? Yes. Very simple concept, guys. True. So because of this, aeroplanes will move in stratosphere comfortably. As there is no vertical air, aeroplane can move easily because no one to disturb it. Okay, everything is interrelated. Anyways, can you write quickly? You wrote this conduction, convection, radiation, advection, reflection below that. You write conduction, conduction, hyphen. It is a process of heat transfer. It is a process of heat transfer which would occur mainly because of contact, mainly because of contact. Full stop. Air is bad conductor of heat. Air is bad conductor of heat. So we do not observe conduction in atmosphere. Conduction in atmosphere. But wherever air comes in contact with hot or cold surface, air comes in contact with hot or cold surface, comma, we observe conduction. We observe conduction. Full stop. Conduction normally occurs near the earth's surface. Near the earth's surface. Next you write convection. Convection. Hyphen. Transfer of heat occurs. Transfer of heat occurs because of vertical circulation. Because of vertical circulation. Full stop. In gases and liquids, we observe convection. Full stop. Next point. In atmosphere, as we move above, as we move above, if temperature decreases, then there will be vertical movement. There will be vertical movement of air. There will be vertical movement of air. Just draw this, guys. Done. Next, you write, yes, conduction is only for solids and not all solids. Next, with increase in height, if temperature increases, with increase in height, if temperature increases, then there will be no vertical movement. Then there will be no vertical movement. Draw this, guys. Done. Thank you. Everyone, for 5 minutes, focus properly. Later, you can ask doubts. This particular concept, understand first. See, this temperature is 25 degrees Celsius. Everywhere temperature is 25 degrees Celsius. Now, I have a metal which I have heated. and it is heated to 100 degrees Celsius. I have another metal heated to 80 degrees Celsius. I have another metal heated to 50 degrees Celsius. Guys, metal is 100, 80, 50. Surrounding is 25, 25, 25. Okay. The property of every hot object is to release the heat to the surrounding. Fine. You just take a case. I will have a hot cup of coffee. I will keep it out. After some time, it will become cool. Where did the heat go? Heat went to the surrounding. So remember, every hot object radiates its heat to the surrounding. So when heat moves from one to another, when it is not in contact, then it is called as radiation. Transfer of heat when there is no contact is called as radiation. I repeat, transfer of heat when there is no contact is called as radiation. Yes. Now you see here, 100 will release heat to the surrounding. From everywhere it will release the heat. Here also it will release the heat. Here also it will release the heat. Fine, guys. Now this will release 75 degrees Celsius. This will release 55 degrees Celsius. This will release 25 degrees Celsius. Yeah, air is also a medium, but remember, even in vacuum it will be there. That is, sun is very hot and we are receiving the heat of the sun, and atmosphere is not there beyond 1600 kilometers. So even in vacuum, anywhere, when there is no contact, if heat is released, then that is called as radiation. So now what we want to understand in this is 100 is releasing 75 degrees Celsius. 80 is releasing 55. 50 is releasing 25. And normally, guys, when I observe, whatever heat is released, heat is normally released in the form of waves. Heat is normally released in the form of waves. Heat comes like this. But if it is hotter, it releases in short wave. If it is little cooler, wavelength increases. If it is much cooler, wavelength increases. You see, if guys, I hope everyone is aware, this is called as wavelength. Here I have shorter wavelength. Here I have longer wavelength. Guys, one basic fundamental phenomena that everyone should understand is, hotter the object, shorter is the wavelength. . Cooler the object, longer is the wavelength. From that point of view, everyone understand and tell me this. I have Earth and I have Sun. Sun's rays is coming and falling on the Earth. Earth is becoming hot. Earth is becoming hot. And then Earth will send back heat in the night. Okay? Earth will send back heat in the night. In the morning, we get heat from the sun. Can you people tell me, sun radiation, Earth's radiation, sun is hotter, Earth is comparatively cooler. I repeat, sun is hotter, Earth is comparatively cooler. So can I say that from the sun, we get short wave radiation? Short wave radiation. And whatever goes out of the Earth, can we call it as long wave radiation? Can we call it as long wave terrestrial radiation? Here, incoming short wave solar radiation. Everyone, do you understand this basic fundamental concept? Whatever radiation we receive from the sun is called as short wave radiation. Whatever radiation we receive from the Earth is called as long wave radiation. Fine, sir. Why are we worried so much about this? Now you see, guys, I'll explain a basic fundamental concept, and this will help you in environment as well. Earth. This oxygen is like this. Nitrogen is like this. Carbon dioxide is like this. Okay. Just giving you example, guys, not accurately, but for your understanding. Now you know what happens. Short wave radiation comes through oxygen. Oxygen doesn't absorb it, just passes through it. Nitrogen also doesn't touch it. Carbon dioxide also doesn't touch it. So when sun's rays will come, oxygen, nitrogen, carbon dioxide doesn't absorb it. It doesn't touch them. That is, sun doesn't heat oxygen, sun doesn't heat nitrogen, sun doesn't heat carbon dioxide. Fine. Let us take the case of Earth. Long wave. Oxygen doesn't absorb. Long wave. Nitrogen doesn't absorb. Long wave. Carbon dioxide absorbs. And you tell me, if carbon dioxide absorbs, will it become long wave rate? Sorry, will it become hot? If carbon dioxide absorbs it, will it become hot? If it becomes hot, can I say atmosphere becomes hot? Can we call this as global warming? Can we call this as global warming? Yes. Yes, very good. Everyone? Ma'am, see, oxygen, nitrogen doesn't absorb sun's rays or earth's rays, but carbon dioxide doesn't absorb sun's rays, but it absorbs earth's radiation. Because of this, heat is trapped. Heat is trapped. Now, and that is the property of the gas, because the molecule is arranged like this. Not all gases have the property. Different gases have different properties, right? Different gases will have different property. This, if you understand, that's enough now. Don't go beyond that. Now, everyone, I'll ask you a simple question. Now, carbon dioxide property is it will absorb only long wave. It will not absorb short wave. That is the property. Clear? It absorbs the short, like, long wave, doesn't absorb short wave. Yes. Now, everyone, I'm bad at drawing. So assume it's a car. Now, you might have observed, when we keep the car in the hot sun, after some time when we go inside, will it be very hot? Yes. Okay. You see this. Now let me tell you the property of this. Bikes, it's anything, but car is preferably, mainly because we have a concept to deal with it. Guys, Norway, Sweden, Finland, they are closer to the poles. They are very close to the poles. And it's very cold, right? It's very cold there. As it's very cold, what happens? People cannot do any agricultural activity. But they observed there, whenever we keep, like, a car outside, inside the car, it is not very cold. Those people there, they saw that when car is outside, inside the car, it is not very cold, but outside it is cold. Then they studied the property of this. Then they found that the car is allowing incoming short wave radiation. Once it comes inside, it is absorbed by the earth. In car seats, like, steering, all those will absorb. After absorbing, it will send long wave back. But the long wave is not allowed by the glass. So what is going to happen when it hits it? The glass sends back. You see, guys, the property of the glass is it allows incoming solar radiation but doesn't allow outgoing terrestrial radiation. Now you tell me, can I say heat is trapped? If heat is trapped, can we say temperature increases? If temperature increases, can I grow crops here? If temperature increases, we can grow crops here. And these type of buildings were called as greenhouse. Is this a good idea? Is this a good idea? Yes? Okay. Now I'll tell you the other way around. Our intelligent people, our intelligent people, what they have done, in Hyderabad, you have IKEA centers. You might have heard of this. IKEA. And it is from these countries only. Fine. Now, in Hyderabad, they have constructed the entire building in glass. Why? Original is in glass, so they want to construct here also in glass. You tell me, is Hyderabad cooler or hotter? Hotter. Will more sun's rays come? Inside, will it become very hot? Now, if it becomes very hot, you have to put AC inside. Is it correct to build the buildings in glass in India? Do you understand? Do you understand the fundamental mistake? Now, you see here, guys. Everyone, see here. Earth. Ozone. Nitrogen. Oxygen. Carbon dioxide. Greenhouse gases. Water vapor. No, not any type of glass. Yes, glasses will also have properties. Based on that, it varies. Clouds. Everyone understand now? Nitrogen doesn't absorb sun's rays. Oxygen doesn't absorb sun's rays. Carbon dioxide doesn't absorb sun's rays. Other greenhouse gases doesn't absorb sun's rays. Water vapor absorbs sun's rays. Does ozone absorb sun's rays, guys? Does ozone absorb sun's rays? Complete sun's rays or only one part of it? It will absorb UV. It will absorb UV. Correct. What does clouds do, guys? Can you tell what does clouds do? Will clouds absorb or will it send back? Clouds reflect back. Good. Now this. Nitrogen doesn't absorb Earth's rays. Oxygen doesn't absorb. Carbon dioxide absorbs. Greenhouse gases absorb. Water vapor absorb. Clouds reflect. Tamana will speak about high altitude and lower altitude clouds. That I'll give you separately in clouds chapter. As of now, remember this. As of now, remember this. That is, clouds reflect sun's rays and earth's rays. Fine. Clouds reflect both sun's rays and earth's rays. Did you understand this basic concept, guys? Some gases absorb sun's rays, some gases doesn't absorb. Some gases absorb earth's rays, some gases doesn't absorb. Now, can you people write down quickly? Clouds will have water vapor also, water particles also. So if water particles are there, it will reflect. If it is moisture, then it absorbs. Now you write radiation. Radiation. Hyphen. Every hot object has a tendency to radiate its heat to the surroundings. Full stop. The transfer of heat would occur even when there is no contact. Even when there is no contact. Next, right? Radiation will be in the form of wavelength. Come on. Hotter the object, shorter is the wavelength, and cooler the object, longer is the wavelength. Cooler the object, longer is the wavelength. So incoming solar radiation, is called short wave radiation. And outgoing long wave radiation, outgoing terrestrial radiation is called long wave radiation. Next paragraph. Different gases will have different properties. Different gases will have different properties. Some gases absorb short wave radiation, and some will absorb long wave radiation. Example below this, you write example, nitrogen hyphen doesn't absorb solar or terrestrial. Next, oxygen does not absorb solar or terrestrial. Carbon dioxide doesn't absorb incoming short wave, but absorbs outgoing long wave. Greenhouse gases like methane, nitrous oxide, perfluorocarbon, hydrofluorocarbon, sulfur hexafluoride, nitrogen trifluoride. Guys, I have given you these names, these 7 names. These are greenhouse gases under Kyoto Protocol. Okay, Kyoto Protocol. And in case in exam, if they ask you any other name, like which of the following are greenhouse gases, if the term fluoride is there, remember the term fluoride. Fluoride absorbs Earth's radiation a lot. So the more fluoride is there, the more dangerous it is. Carbon dioxide. Here it is perfluorocarbon, hydrofluorocarbon. CFCs nowadays, it has been reduced, ma'am, so we don't say. And most importantly, CFC is also greenhouse gas, but CFC is reduced under Montreal Protocol. So we are not reducing it under Kyoto Protocol. Okay, just those references, nothing much. Next is, next. You will be reading all this in environment. Next you write. Yes, there is a protocol called as Kyoto Protocol, which aims to reduce greenhouse gases. And they have identified 7 greenhouse gases. And these are the 7 greenhouse gases they have identified. Chlorofluorocarbon is also a greenhouse gas, but it is under Montreal Protocol. Yeah. Next you write water vapor. Water vapor hyphen, it absorbs both incoming and outgoing. It absorbs both incoming and outgoing radiation. It absorbs both incoming and outgoing radiation. Now you tell me, guys, I have dry air, I have moist air. In moist air, water vapor will be more. Dry air, water vapor will be less. Which one will become hot sooner? Moist becomes, because moist absorbs incoming also, outgoing also. Next is, you write clouds. Clouds. Clouds hyphen. Different type of clouds has different properties, but most of the clouds reflect both solar insolation and terrestrial radiation. Both solar insolation and terrestrial radiation. Okay. So yes, this is about what we call as, like, radiation. Reflection, I need to talk. Tomorrow morning, we'll be discussing that. Some new students were asking for the number. You can text me on Telegram and WhatsApp. Some South Indian students were also asking. So guys, Hindi I'm comfortable, but not to explain. But in case if you have any issues, you can ask me. Other people also, Telugu, Kannada, I can talk. So yeah. Telugu, Kannada, comfortable. Hindi, I'll manage. Will try my level best to help you people out. Okay. Fine, yes, we'll see tomorrow. Thank you all.
Thank you, sir.
Thank you.
Thank you, sir.